All right, so I am going to this video will be kind of a work in progress because I'll be holding my phone while also doing the actions of everything on the table. So up here we're gonna have the stimulus, and this pencil is gonna represent the neuron. So let's say like that's the dendrite, goes to soma, axon, etc. So when the stimulus comes near the neuron, this will trigger local or action potential. So, while this moves, it will be represented on the graph. And then over here, this will show you what's exactly going on inside. So, the dark pens are showing where the basically cell membrane is. And then here are the two gates. So this one is the potassium gate, because down here we have the potassium atoms chilling in here in the ICF. So down here is the ICF. Up here is the ECF. Here is the sodium gate, and here is all the sodium up here in the ECF. So there are, as you notice, more sodium than potassium. They're both positive, so there's a little bit of both, but there is more sodium in the ECF. It is slightly more positive. So right now, with the stimulus at the distance it is not interacting with the neuron at all. So we are in what would be called resting. So we would basically be at 70 here. So we're just kind of hanging out at 70. And if I take my marker, let's just say this is where we are, okay? We're just hanging out. But if we were to move the stimulus a smidge this way, so now we are closer to the neuron. And when we get closer, that stimulates the dendrite. So that the sodium gate will open. So the sodium gate opens, and a little bit of sodium comes in. Just a little bit, because the stimulus only came close just a little bit. So that it'll come in, and then the gate will change. So then it'll bring some sodium here into the ICF. So now this would be known as a local potential. So it'll go up just like a little bit. But eventually it will go back to resting. So it'll go back in, it'll close back up so that everything is balanced again. And we're back at 70. So we'll just come back down like nothing crazy happened. So we're just chilling at 70. And that's because the stimulus is back in its regular position. So when the stimulus moves a little closer, just a few sodium ions will enter the ICF, causing just a slight influx, which would be known as like a local potential because it wasn't anything major. However, if this stimulus were to, let's say, touch the dendrite, like let's say the stimulus is very close and therefore this is a large fire, one could say. So the sodium gate will open up and a lot of sodium ions will come crawling in, and they're just like, oh my goodness, we need to come in. And then they will diffuse into the ICF, causing what is known as depolarization. So this will cause the chart to reach the 55 because the threshold has been reached. This is more than basically the membrane can handle. you could say. So it reaches 55, and it even goes over 55. So let's say it goes all the way up, and 35 is the largest action potential it can have because of the stimulus. So we're at 35 right now, and this is not cool because it wants to be at its neutral position at -70. So, because it wants to be at resting potential, that means that the sodium gate will close. The sodium gate will close, and the potassium gate will open because it's been triggered now. So that means that the potassium ions here, don't mind little sodium trying to creep in, the potassium ion will all rush in. They'll all rush into the gate, and they will be brought back over to the other side. So they will go out into the ECF as a way to try to balance itself again. So when this happens, when the potassium enter the ECF, then something known as repolarization happens. So that means that this is brought all the way back down here very rapidly back down to 70, because now it's balanced again. There is more sodium down here, and it's still positive, and it's still positive up here with the potassium, but now they're quote unquote equal, and this can close, and it can be happy again, basically. And then it will take a little bit for this just to kind of neutralize out a little bit. It'll kind of wobble around until it's back at its resting 70. And once it's back at its resting 70, the stimulus is no longer affecting it. So all the gates are closed, and each ion is in its designated area.